Hello. You can't really do anything if you don't start it. That's my motivation for today. So today I'm going to start working on my new bench. This is my home desk that I made, and it took me quite a while to set this up, and it's a more relaxed space. I can do more relaxed jobs here, maybe repairs, but and also I can build more electronics here, of course, because it's a more relaxed space. It's not like the shop where you have to pay attention to the money, the time, and all that. So this is a working bench. It's quite a small one, very small. You see, quite small. Just a few things can fit here, but it's okay. We can do a lot from here. So if you are wondering what these things are electronic cigarettes. These ones here, they are electronic cigarettes. They come in different sizes and different flavors. That's why they have different colors. These ones I got them from someone, and they came in as new. He said they are new, and but they are not working. It looks like the batteries are down. So we're going to be charging these electronic vapes. So quickly, these electronic cigarettes, they are more like cigarettes, and it's more of a culture in some of the Western countries already, and they are more of cigarettes. They have 1.7% of nicotine. No tobacco here, but 1.7% of nicotine. And I'm not sure what the nicotine content of a regular cigarette is, but these ones, if you are smoking this, or if you are vaping, or whatever I want to call it, it's still more of a cigarette. People buy them for maybe a night, for a while, and these ones, they are non-rechargeable. But we are going to find our way around it. We're still going to charge them anyway, because I did some findings, and I tried to find out how the things work. And these ones, they are recycled. They are recycled the way they say it. They are to be recycled. That means they throw away after one use. There are some that come in, I guess, with charging ports and stuff that you can easily put in the product or whatever thing that is inside that you want to smoke, and it's going to work. But these ones, they are the ones that you recycle. So the body is made of aluminum. First, it's aluminum out here, and it has a battery and the liquid substance that is inside. And I'm going to open this one, so we'll see how it's working. So how do you open this one? Easy. You just have to turn on this one on the head. This is the cap, and this bottom here, you have to turn on this one on this cap and the bottom to pop open the the two ends. But this one is still new, so it's quite strong to turn that way. So I'm going to get a pair of pliers and try to force open that one. I have a cutter here. Let's see if this one works. No, it's a bad idea. So okay, I'm going to use my teeth. Okay, it's open. You can do it the way I do it. I just use my teeth and it came out very easily. So this is the cap, you see, and the bottom too. I'm going to tighten this hand. Yes, and it's out. So we have the heads open, and we're just going to find a way to push out. Here we'll push out here. Get a tester. And it's out. So I opened a few of these things already. That's why I know what's inside. Focus. You see the liquid inside is actually leaking. That's not bad. So I was curious how the things work, and it's very easy the way it works. It has a simple working principle. So it has a battery right here. I'm not sure. Yeah, 3.7 volts battery. So this thing can work at 3.7 volts. And right on the bottom here, it has like an air sensor. It has some kind of air sensor here. That it has 3 pins, of course, the power. So it has power from the battery, plus and minus to the sensor. Here, excuse me. The plus and minus is from the battery to the sensor. I just touched on it. Yeah, the plus and minus is from the battery, and a third pin, which is probably an output pin that goes all the way to a coil inside here. A coil in this plastic thing, and there's a coil in the middle here. Let me open this one up. There is a coil in the middle here that actually heats up. Let me close up here. Yeah, a coil in the middle here that actually heats up the substance that is in a foam. You see, there is a foam inside here, and that is the substance is actually soaked to that foam, so it's heating up and then it comes out as vapor. You know, this is a liquid on whatever is inside, I don't know, and if it's heating at a high temperature, well, the coil that is in the middle, if it's heating at a high temperature, then obviously you're going to have vapor and not smoke. It's not burning. So the liquid is burning at a high temperature, so you have a vapor and not smoke. It's not solid like the cigarettes that are burning to give smoke. So the working principle is very easy. So our concern here is the battery. So if this thing is working fine, you can have a low battery, but you still have whatever you want to smoke inside here. right? Is that how it is? No, like this. Yes. So you can have a low battery, and you still have whatever you want to smoke that is inside here. That is why I think you can charge the battery to benefit from this, even and you won't have to throw it away before it actually finishes up. So I'm going to check on the battery and see what power we have on the battery. There are some insulation there, that's fine. So I'm coming my multimeter. My meter is in DC, and I'm going to check right here on the battery what we have. We have 3.2 volts. 3.2, and the battery is rated 3.7 volts. So it means that it cannot work. It's not going to have any air. Okay, what am I saying? It's not going to have, you are not going to get the vapor out at 3.2 volts because it's too low to turn on the coil that is in the middle here. So we can't have any vapor from this one. The battery is actually low. That goes for all of these. They are all the same. I tried to take a couple of puffs on all these ones, and they have no vapor. It means all the batteries are down, but they are all new. So we can do something. Let's try to reverse. Let's reverse the thinking, because these things were actually going to be thrown away because they are not working, obviously. So now we have a problem. I don't have, let me clean up here. 1 second, let me get rid of this. Okay, so we have a problem here, which is I don't have a power supply on my bench yet. I don't have a 5 volts power supply for us to charge this battery, which is why I want to make a power supply that's going to permit me to charge this battery and maybe the rest of the batteries for the vapes, and we hope it's going to work for all of them. And quickly, this is what I'm going to be using. I'm going to make a linear power supply with this transformer. This is a 12 volt step down transformer, which is rated I don't know the current output. I'm not sure of the current output. Three amps. Oh, that's a lot. 3 amps. Okay, so this is a 12 volt transformer, 3 amps current, and I have a socket. Should I say socket? And I have this cable that I have connected to the primary side of the transformer for the AC mains input. So this one is going to be helpful, and I have a rectifier, or a full bridge rectifier if you want, and I have a voltage regulator, a 7805 voltage regulator, which is actually going to give us a steady 5-volt voltage, a steady 5 volt for our power supply. Yeah, but we have so much current, 3 amps. Anyway, let's get going. That's not the issue for now. Let's just make the 5 volts power supply first. So the way we're going to start with this one, get a pen. You know, it's very helpful if you want to build things, then you have to draw them down, because you can get lost in the process. You can find yourself on the sketches that you're making, or it's very essential, that's what I'm saying, to always draw whatever you're building. I thought I could do this at first. I thought I could do this without drawing. But it's just complicated when you want to do more complicated things, so it's important to draw. Except except you know what you're doing, of course. Alright, so first, this is the power supply. The transformer is the power supply, and it has like a primary and a secondary winding. The primary winding is where you get your AC mains voltage, which is the 220, and on the secondary, which is this one, we have 12 volts. That's what this one is saying. And this one is nice. It has like an input fuse here, so it's actually protected. That's good. It has a fuse in here. So quickly, we are going to check if the transformer is okay. If it's working, then we should have 12 volts on the output. Okay, so I have it on power, and I'll check on the secondary. So I'm checking from here to here. What do we have? Nothing. Okay, I have my meter in DC, so put my meter in AC, and we have 12 volts. 12 volts on the output, and from here to here, green to green, we have 24 volts. We don't really need a 24 volts, that's too high, we don't need that. So we're going to be using the green and the black. So we can actually cut this one out. No, bad idea. Maybe I can use this transformer for something else, maybe in the future, so I don't have to cut it. So we're sure it's working, the transformer. That's good for a start. Okay, so if you have to draw, we'll have something like this. So this is what our transformer is looking like. Like this. You have like that insulation in the middle, and you have one input like this. In our case, we have two. So from here to here, we have from here to here, from here to here, we have like 24 volts, and from here to here, we have 12 volt AC, and here is the input, which is our 220 volt AC. Good. So we don't really need this. We don't really need this side. We don't need this side. I like to use the colors. We don't need this one, but here, which is 12 volts AC, we're going to use this one. So we have our transformer here, and right next after the transformer we have a rectifier bridge. You know, the rectifier bridge is converting the AC to DC. Is that the word? Rectification, full wave rectification if you want. And the full wave is only when we have a DC at the end. So at the back of your mind, if you are building a power supply, you will have at the back of your mind, this is what you want to have. You know, the AC is like this. That's the waveform of the AC. So in our case, we have 12 volts. On this side, we have minus 12. So the AC is fluctuating like this at the same frequency as the input, which is 50 Hertz. And the DC is looking like this, and that is what we want for our electronic circuits. We want a DC that is like this. So this is AC and this is DC. At the back of our mind, this is what we want to achieve, this one. So the rectifier bridge is good for something like that. Where is it? Yeah, this is a rectifier bridge. So how am I going to draw the rectifier bridge? Rectifier bridge. Okay, I don't want to draw the rectifier bridge, but I'll draw 4 diodes. You know, the rectifier bridge also, it has 4 diodes inside, and that's how it's working. At every instant, it is like this. It is one diode like this. Alright. Another one like this. So that's the internal structure of the rectifier bridge. Correct me if I'm wrong. I guess that's it. So we have these two